Hello, my name is Jacob Steger, and my project is Bayesian phenology modeling. Phenology is the study of cyclic natural phenomena, looking specifically at the timing of the first leaves and flowers of the spring in plants in New York. Phenology is an important tool for ecology and studying climate change. I'm looking specifically at what environmental variables impact the timing of the first leaves and flowers as they emerge, as well as how invasive species respond differently to these variables compared to native species. I also want to see how the models I make match data from later years. I'm looking specifically at invasive and native shrub and tree species from 2018 to 2022 in New York State. The variable I'm looking at is the day of the year of leaf or flower emergence, which is the first case of 5% or more leaves or flowers. And this variable is limited from 1 to 171, or before the summer solstice, so it captures the spring. My first model is a Bayesian linear model, and the second model is a frequentist linear model, which both have the same parameters of temperature, latitude, and elevation as continuous variables, and tree or invasive as categorical variables. And I also have as a third model a Bayesian hierarchical linear model, which has a similar set of variables excluding the invasive variable because it is part of the hierarchical setup where there is either the native or invasive model. And looking at the results, all three models were nearly identical across all of the models and flowers or leaves. And as a quick overview of the results, the invasive species are more affected by temperature and latitude than native species, but less affected by temperature and elevation. They get their leaves earlier, but don't have any difference in flowers. And this is important to consider for any phenology observations in the future.